All right, if we look at these next ones, the big, really important thing that we're going to be dealing with for the rest of this chapter about logs is that logs and exponential functions are actually inverses of each other. If I had you graph a log function today in comparison to the exponential function we did yesterday, you would see that they are actually inverses of each other. So when you look at a problem like log base b of b to the x, what these two things do is they cancel each other out. So all you get left is x. A log function and an exponential function will cancel each other out. So same thing happens here. This is your b. The first b represents an exponential function because there's an exponent. Do you see there's an exponent? Yeah. And then the log is a log function. Those are going to cancel. So this next section should actually be super easy. But this is just getting you used to. We're going to be doing equations with these when we get back from Thanksgiving break. If it has the same base for the log and the same base of the exponent, if these two bases are the same, they just cancel each other out. So the answer here is just that 8. So then when you look at 3, this is the other, or 2, this is the other version of it. This has the base of 3 and a log of 3. The exponential function's base is 3, the log's base is 3, so they cancel each other out. As long as they have the same base, they cancel each other out. They're inverses of each other. You just get 17. They're inverses of each other. It's like multiplying and dividing. A log and an exponent are inverses of each other. And you're going to see this even clearer tomorrow when we start to talk about the properties. But they're opposite of each other. They cancel each other out. It's like taking a square root and squaring it. If you take the square root of a number and you square it, don't they just cancel each other out?
So does the second one cancel out because of the 2 3s?
Because they both have 3. Because this is a 3 and this is a 3. Because the bases are the same. If the bases are the same, they cancel each other out.
Okay. Why are we doing the hard stuff when college is still better?
What's going to happen in 3? The log 5 and the 5 cancel, so you just have the 2x left. You need to start to see that they cancel each other out because they're inverses. Like, those of you that are stuck here, if you saw this right now, if you saw this, what happens? They cancel each other out, right? That's what the log and the log base 5 and the 5 are doing. They're inverses of each other. They cancel each other out. So you're only left with that, whatever was in the exponent.
So just 2.
So in 3, it's 2x because the x was there too. But for the answer I did, it would be 2. But that's the same thinking process that you need to think through when we do these. All right, the next thing we're talking about is what's called the common logarithm. What you need to start to realize is that if you see the word log by itself, there's no base. Log without a base means there's actually an invisible 10. That's called the common logarithm. So if you don't see a number there, you can always put a 10 in. They'll give you a number or they won't give you a number. If they don't give you a number, it's automatically 10. So when you look at this one right here, when you look at this one right here, you can technically squeeze a little 10 in here. And then what happens with log base 10 and 10? So the answer for this is just x. We're going to see that in the next page. So then if you look at, actually I made a mistake here. Pretend that x isn't there. That x is supposed to be up there. Because what's going to go here? If it's just a regular log and there's no number, what's going to go there? 10. And what's going to happen with this 10 and the log 10? They cancel, so you're just going to get x. It's supposed to be where the x is. The x isn't supposed to be in that little position. It's supposed to be... Yeah.
No, like in the other one too, like why?
It sounds like some of you need some time to work on your homework, so you can ask me questions today. Hi, Vernell. All right, the last thing we're looking at, do you remember we talked about E yesterday? If you looked back at your notes, I told you E is called the natural base. E is called the natural base. It has its own log. The inverse of E, the inverse of E is called ln, which is called the natural log. You get to see natural base, natural log. They're related to each other. So if it says log E, that's actually the same thing as saying ln. ln just stands for the natural log. So if you look at the next two problems, if you see ln and e next to each other, if they're inverses, what do?
Cancel.
They cancel, so you just get x. If you see e with an ln in its power,
Cancel.
they cancel each other, you just get a x. So now you have 4 examples covering the last 2 inverses I just showed you. The first one says ln and e. What's going to happen with ln and e?
Cancel.
So what do you have left? 25x. The next one says e to the ln. They cancel. You just get the square root of x as your answer. Those are they're inverses. They cancel each other out. When you look at 3, when you see log and there's no number there, what number is technically there? There's technically a little 10 down here that you don't see.
It's always 10.
If there's no number, it's automatically 10. If there's another number, it's whatever number's there. But if there's no number, it's automatically 10. These cancel. You get 1/2. Same thing and then 4. If it's log with no number, there's a 10 there. The 10 and the log 10 cancel, so you get 6.4. You guys freaked out on me with this inverse stuff. If you see a log with the same base, and then you see an exponential function with the same base, they cancel each other out.